Okay. All right. So this is what we have discussed. Okay, we are talking about process integration. Okay, and the objective is to do the process integration is to make sure that you have the reduction in the energy requirement. So that is the most important objective of doing pinch technology, because this is not required. Okay, so that's why when you build the plant, okay, you have to have certain data, okay, to see how much energy is required for your process. Okay, so when you know how much energy is required for the process, then you know how much cost will be involved. Okay, and then when it's involved cost, okay, is it variable for the industry to carry out the present setup for the energy requirement? If it's can bear the cost involved for the energy requirement, then you don't have to put, they don't have to proceed with the process integration. But normally, when you talk about energy requirement, this is the most highest cost that's involved in the process. Okay, so that's involved utilities such as water, such as electricity. Okay, so you have to have some ideas regarding to this. Okay, so same thing when you are at home, the utilities involved is very expensive. Okay, it's just that in Malaysia, when you consume an electrical energy at home, you have certain costs that you need to pay. Okay, but if you compare with the industry, they pay more more cost per unit energy that they have to bear. Okay, compared to home consumption of electrical energy. Okay, so same thing, if you upgrade the electrical phase at home, okay, the ordinary phase is a little bit different compared to the higher three phases electric setup at home. So it depends on the size of your house and the requirement of energy that you need for your house. Okay, the more energy you need, the more expensive that you need to pay. Okay, all right. So our focus is about the chemical process plant. All right, about the chemical process plant. So this is actually how you manage the financial for that particular company that you would like to set up. Okay, first of all, you need to have some ideas regarding to how much energy that will be required by the plant that you're going to set up. So once the plant has been set up, then you can see you're going to get certain data, you're going to collect certain data, okay? And then you have to make some decision, okay? Few decision, top management got to look at this cost and then whether the process integration should be carried out or not, okay? All right, so this is the most latest technology about the energy requirement. So majority of the industry who required high energy requirement, they adopt to this process integration. Okay. All right. So another thing I have mentioned regarding to the heat exchange network in the last class. Okay, I do hope that you have some ideas regarding to heat exchange network. So this involves process integration, all right, and then it's involved hot stream and cold stream. Okay, so the hot stream, the objective is to make sure that when you talk about heat exchange network, the objective of having high temperature for the hot stream is to have lower temperature at the end of the hot stream. Same thing for the cold stream. Okay, the objective is to have the final or the exit or the outlet temperature of the cold stream should be higher compared to the inlet cold stream. Okay, so the temperature represent the materials that you have in the stream. Okay, so you can have any fluids in the stream that you have. Okay, so every stream will consist of any fluid that has its own heat capacity. Okay, so for water, you have different heat capacity. For the petroleum, you have different heat capacity. All right, so therefore, you need to have what are the fluid that's involved in the hot stream or cold stream. They don't mix to each other because you need to control the materials that you have on different stream. Okay, all right, but to have the process integration, you're going to have heat exchange network. Okay, where you can save energy that will be required by the process. Okay, at the same time, you can increase the profit for the production. Okay, all right, so there are many ways to look at it. Okay, so the delta T minimum, here represents the delta T pinch that you're going to deal with. Okay, so when you want to deal with this delta T, okay, you have to look through the delta T minimum that has been recommended that is possible for you to have. Okay, so if you were to have smaller difference, okay, okay, for your delta T, that will be good enough. Okay, but if you cannot manage to have delta T, at least you follow the guided materials that has been recommended by industry, practiced by the industry, where they follow this particular guide, and it will give the effective choice for determining the delta T minimum. Okay, so when you talk about this, all right, okay, so the pinch represent your delta T. Okay, your pinch represent by your delta T. Okay, the pinch temperature should be stated. Okay, the pinch temperature should be stated, and what would be your approach. Okay, all right, so we have to make choice. Okay, what is the approach for the cold stream, the pinch for the cold stream, and the pinch for the hot stream. Okay, so we have to determine that. All right, so if you think that the pinch here represent the temperature that you have for the hot stream, or let's say you want to choose the pinch for the hot stream is 100 degrees Celsius, then all the calculation must be referred to the pinch at 100 degrees Celsius. There are many formulas involved here, actually, but it depends on the questions given to you. Okay, all right. So for let's say you have the pinch given to you is at 90 degree, or you have to follow for the cold stream 90 degree, because the difference between the hot stream and the cold stream is about 10 degrees Celsius. All right. So you need to select the pinch for the process. Okay, the pinch for the process. So if I can show you here, okay, for the hot stream, all right. Okay, let me point out here. Can I? All right, this one. Can I use something here? Okay, so this is hot stream. You know, this is a hot stream. Okay, so the pinch temperature should be at this point. Okay, at this point. Okay, for the hot stream. Okay, so if you draw a horizontal line, okay, if you draw the horizontal line here, that will be the pinch temperature of the hot stream. Okay, the pinch temperature of the hot stream. All right. So if you choose to have 10 delta T minimum to be 10 degrees Celsius, then therefore this one is 100, therefore the cold stream should be at 90 degrees Celsius. So the pinch temperature for the cold stream will be 90 degrees Celsius, so that it will give you delta T minimum to be 10 degrees Celsius. Okay, so any question?
No, Miss.
Okay, good. All right. So this is the choice for you to make, okay, based on the system that you have. Okay, so you can have a very small pinch if you can afford to have that. Okay, so look for the cold stream. The lowest temperature is given by, let's say, this one, the pinch temperature for the cold stream. That is the lowest temperature of the cold stream. Okay, so it doesn't mean that you always have to refer. If you have two of them, then it is easy. If you only have two stream, hot stream and cold stream, one hot stream and cold stream, then it's easy for you to determine the pinch temperature for both stream. But if you have more than one, then you have to make choice. Okay. All right. So let's see the next page. Okay. All right. So this is another way of doing that. Okay, if you have more than two streams, again, more than two streams. Okay, so by having that, you have to know that we are talking about the heat capacity given to you. Okay? What is heat capacity? Right. So heat capacity, you learn your physics in Form 4, I know that. Okay, you learn about specific heat capacity, you learn about heat capacity. Therefore, you should understand what is heat capacity. All right. So if you don't remember what is heat capacity, please refer to the definition of heat capacity. Okay. All right. So your job is to search for the information. You learn about heat capacity, you learn about specific heat capacity. Okay. By looking at the unit, okay, by looking at the unit, you have kilowatt per degree Celsius. Okay, you have kilowatt per degree Celsius. Okay, you can have other units. You can have kilowatt per Kelvin. It doesn't matter. Okay, but it will refer to what you need to be used consistently in the calculation. Okay, in the calculation, right? So if I can brief you a little bit regarding to heat capacity, okay, that will be the amount of heat which is required, okay, which is required to increase the temperature of a given mass of substance by 1 unit of temperature. Okay, so this involve without change the phase of the material. Okay, without the change of material. So heat capacity also known as thermal capacity. Okay, so in simple word, actually, in simple word, it describes as the substance ability. Okay, the ability of the substance to absorb thermal energy. Okay, to absorb thermal energy. Okay, all right. So the complete explanation, you can always Google and find that information. Okay. All right. So I explained to you how to do the calculation on to find the heat load. Okay, the heat load. All right, meaning that if you have the initial temperature and you would like to have final temperature, what is the difference between the magnitude of the temperature that you have? That will give you the heat load. Okay, different in temperature, you multiply with heat capacity to give you the heat load. Okay, so same thing for the cold stream. Okay, it doesn't matter whether the value is negative or positive, as long as you have the difference between the two temperature that you would like to achieve, then you just multiply with the heat capacity, okay, and then you get your heat load. Okay, heat load, yeah. All right, so that is what I have explained in the last class. Okay, all right. So there are many methods lah to do that. Okay, there are many methods. Okay, we just want to use a very simple method. Okay, very simple method. Okay, so if you were to use that particular certain method, then there are different calculations involved. Okay, all right. Then I'll show you regarding to the heat exchange at work a little bit. Okay, all right. So if you look at this, just look at this. All right. So if you were to have heat exchange at work, given the pinch is 85 degrees Celsius, then you can play around with this. Okay, 85 to, okay, what do you want to have? Okay, what do you want to have? So if you follow the previous formula, okay, the hot stream will have 90 degrees Celsius, okay, and the cold stream will have 80 degrees Celsius. All right. So if you refer to this, it will be the one that you look at here. This one. Okay. All right. So today I just want to explain regarding to a simple method, which is just to choose your pinch for the cold stream. Okay. For example, okay, we don't look at this first. Okay, just look at what we want to do. Okay, so we want to do where the pinch the pinch temperature for the cold stream is 80 degree, and the pinch for the hot stream is 90 degree. So that you get the difference of delta T is equal to 10 degree Celsius. Okay, so then you need to calculate what is the energy load required. Okay, what is the energy load required? Okay, so after that, you need to arrange the stream, label the stream, the hot stream and the cold stream. As you can see, stream number 1 and number 2 is considered as hot stream because the final temperature needed is lower. Okay, and the stream number 3 and 4 is considered as a cold stream because the energy need to increase the initial temperature to the higher temperature. Okay, so then later, okay, after you do this, okay, you need to look at the choices involved. Okay, choices involved. Okay, all right. So I'm going to share this in another screen on so that we can do the calculation. Okay, so kita buat calculation biasa sahaja. Okay, hold on. I need to use the whiteboard. What is that temperature? 180. Okay, hold on. Okay. All right. So, okay. Share the screen. Okay, so if you refer to the quiz that I've given to you, okay, I've given you the quiz questions in the Telegram. Okay, so these are the method that you need to follow to solve the quiz question. Okay, so after this, you have to do this question in the sample quiz that I've given you in the group. Okay, all right. So before that, okay, so we are talking about the string, this particular string. Okay, this particular string, right? And the objective is for you to draw this particular, okay, where is it? Okay, for you to have drawn this particular diagram, okay, to know how much energy is required for each particular string, okay, and definitely, okay, you need to know how to calculate this heat energy load. Okay, I've explained to you already, right? Heat energy load. Okay, the objective is given already where you need to know the initial temperature and the final temperature. So you always have to know what is the initial temperature and final temperature of your stream. Okay, because that is needed by the equipment if you need to use the materials in the stream. Okay, if you need the materials in the stream for other process. Okay, all right. So based on this, you have 360 degree. It's 360. Your heat load is 360. Okay, for the hot stream and 120 kilowatt for the stream number 1. Okay, now so you need to manage, okay, because you have decided the hot stream to be the pinch temperature for the hot stream is 90 degree. Okay, 90 degree. All right. So you have to look at the calculations involved actually. Okay. So what is the calculation involved? Okay. So the requirement should be stated here. Okay. So you just copy first how much energy heat load that you need here. So for example, you need the heat to be, here is the first row, make it bigger. Okay, so you have here, you need about 300. Okay, you need about 360 kilowatt. Okay, kilowatt. For the second one, you need 120 kilowatt. Okay, the third one, you need 230 kilowatt. Okay, and the fourth one, you need about 270 kilowatt. Okay, so by looking at this, all right, so you can make choices. Boleh buat choices lah. It must be one hot stream and one cold stream. Okay, look at the differences that we have. Okay, now we are talking about, okay, look at this hot stream. Okay, 150 to 30 degree. The energy required is only 120 degree kilowatt. 120. But the cold stream has more than that, which is 230 kilowatt and 270 kilowatt. So therefore, you can match stream 2 and stream 3, or you can match stream 2 and stream 4. You can do that. Okay, but we want to think about what is the best that you can have for your exchange, for your heat exchange network. Okay, and then look for the top one, which is the hot stream. The energy required to reach 60 degrees Celsius is 360 kilowatt. Okay, 360 kilowatt. All right. So if you were to choose the first one, you the third stream, you can choose that one. But if you can also choose stream number 4 because energy that have in the cold stream here is the higher one is 270 degree. Okay, so meaning that if I want to deal with stream number 1 with stream number 3, okay, with stream number 3, okay, I need to have cooler in front here. Okay, cooler in front here, where the cooler required energy 360 minus 230. What is the number? 70 kilowatts. Okay, 70 kilowatts, right? So if I have this one, we just play around. Ni you kena buat practice. This one and this one, you need about 40, 30, 70. 70 kilowatts. Okay. But if you want to match this one and this one, you need about 30. So, saya kira. Salah kira. Salah kira ni. Okay, lagi sekali. Okay, kira betul-betul. Okay. So let's say ini dengan ini. Okay, you have this one. Berapa different dia? 70 dengan 60. Berapa? How much? How much? What is the difference?
130, Miss.
100?
30.
130.
Yes.
Okay, kilowatts. Okay, so if you want to match this one and this one, how much?
90, Miss.
90. Okay. Now, so what is happening here is that, all right, so you have to look at a pair. All right. So the pair that we have here, let's say this one, stream number 1 and stream number 3. Okay, stream number 1 and stream number 3. Okay, so if you integrate between the stream number 1 and stream number 3, stream number 3, you don't need to have heater. You don't have to have heater here because heat transfer is enough from the hot stream. Okay, heat transfer is enough for the hot stream to make sure that stream number 3 reach 135 degrees Celsius. Okay, 135 degrees Celsius, meaning that this will be cancelled. No need energy here. Okay, but you get the energy from here. Okay, you get the energy from here, but left with 130 kilowatt lagi untuk cool down the hot stream. Okay, because 360 you donate 230 kilowatt, you donate 230 kilowatt from 360 degree. Therefore, it's enough to make sure that stream number 3 will have the outlet temperature to be 135. But only 230 watt is used from here. Left you with 130 kilowatts. Okay, so if you were to make choices between these and these, okay, you need cooler here. Saya bagi you case by case. You need the cooler here. Mana saya nak buat? So let's say kita duplicate dulu page ni supaya nampak. Boleh duplicate. Satu. Okay. Okay. So now is page 31. Okay. So what happened? You need a cooler here, this position. So you need cooler. Saya buat pen biru lah. Cooler. You need to install cooler here. Okay. So this cooler will give you the information on the particular part that you have. Okay. All right. So the cooler that you have. Okay. So the cooler that you have, for example, is here. And this cooler required water with the required energy to be 130 kilowatt. Okay, so dia perlukan cooler at 130 kilowatt energy. Okay, so if you were to choose that, okay, but if you were to choose between, okay, sorry, ada dia. Satu. Okay. Okay, tak apa. Rasa copy. This one, but doesn't fit. Times. Okay. Okay, now if you were to choose between stream 1 and stream number 3, okay, so what happened? What happened? Now you have to tell me what happened. How much energy has been used? Do you need any heater for stream number 4? Do you need heater for stream number 4? Energy can be transferred from stream number 1 to stream number 4. Okay, if you choose this one. Okay, so do you need to have heater here for stream number 4? You don't need. Okay, because heat energy that you have here, okay, and the heat energy that you have here is enough to be transferred. Okay, enough to be transferred. But what's left? What's left from the hot stream? So you have about 90 kilowatt. Okay, ada 90 kilowatt lagi to cool down the process. Okay, for the hot stream. Okay, so you might want to install cooler here. You need to install cooler here. Okay, where the cooler need about 90 kilowatt of energy. Okay, so is this the best choice? Just look through again. The first one required only 130 kilowatt of energy, but the second choice needs 90 kilowatt of energy. Okay, so it depends lah. You nak ambil yang mana? 130 ke? You nak ambil 90? Which one is better? Which 90. One is better? 90 is better because you need or you require less energy. You require less energy for the cooler. Okay, so once you make that choice, right, then you go ahead with the second exchange network. Okay, so you can build one heat exchanger to connect or to integrate, okay, from stream number 1 to stream number 4. Boleh lah, macam tu tak ada hal. Okay, tapi kalau you make the choice, yang the first one tadi, between stream number 1 and number 3, you require cooler much, your cooler required more energy, required more energy, alright? So more water lah, more energy means more water needed to cool the stream. Okay, alright, next, what happened if, okay, now you have made the choice between 1 and 4. So kalau dah buat choice tu, 1 and 4, okay, 1 and 4. Okay. So sekarang, kita padamlah yang lain-lain tu. Okay. So you kena padam. 1 and 4 dah settle. Okay. Sekarang tinggal okay. 3 and 2. 3 and 2. Okay, tengok 3 and 2 dulu. Okay, 3 and 2. Okay, berapa energy tadi? How much is the energy just now? Hilang dah. 3 is 2 need about what? 2 tadi berapa? 120 eh. Inilah you kena fikir dalam test tadi. So this one is 120 kilowatt. The second one is 230 kilowatt. Okay, 230 kilowatt. Okay. All right. Now, do you think that you want to match stream number 1 and number 3? Boleh ke tak? Boleh ke tidak? 120 ke? Boleh ke tak boleh? Kenapa lain dia? 120 bawah 230. Betul lah. Betul ya kira tadi ya? Okay. 150 degree, 30 degree, 135, 20 degree, tapi heat capacity dia lain-lain. So that's why the required energy needed is 230 here. Tengok ni. Ni 230. Sikit. 230 kilowatt. Boleh ke tak? Possible or not? Boleh ke tak? Logically. Can or cannot?
Boleh kot. Saya nak kot.
Okay, tak boleh. Kenapa? Okay, first pandang satu-satu dulu. Is the cold stream number 3 ni enough untuk cool down the stream number 2? Enough tak? Enough ke tak enough? Enough ke tak enough? Ataupun you can look two ways. Okay, stream number 3 cukup ke tak cukup nak sejukkan stream number 2 ni? Cukup ke tak cukup? Cukup energy tak nak tolak?
Cukup.
Cukup kan? Tapi
Yes.
stream yang bawah ni akan ada balance lah. Betul?
Betul.
Betul tak? Betul. Dia macam tu lah fikir. Alright. So kalau enough, meaning that you settle down stream number 2. Tak perlu fikir dah nak letak cooler. Nampak? Tak perlu fikir dah nak letak cooler. Alright. So if you want to match, saya bagi you nampak dulu. Okay. If you want to match, okay, sekarang ni, ini kita match, saya buat dengan pen merah. This one and this one settle. Dah berlaku. Cantik. Okay. This one. Okay. This one and this one dah berlaku. Okay. Alright. Tapi dia perlukan cooler dekat stream atas tu. Ada 90 tu, cooler tu. Okay. Then, if you want to settle between stream number 2 and 3, it is enough already. Okay. Maksudnya, sini masih ada extra cooling, masih ada. You need to install. Okay. You donate this one and this one. Okay, you donate okay. So you bagi 120 left with 230 minus 120 apa?
110.
110. So you need heater here. Yang ada balance 110 kilowatt. Okay. So stream number 2 settle lah. Stream number 2 settle. Stream number 3 settle. Okay. Kalau ikutkan settle lah. Right. Settle lah already. Okay. Maksudnya you have the pair for the stream. Okay. Boleh settle macam tu. Maksudnya no need to have a heater for stream number 4. No need to have cooler for stream number 2. Okay. But you need cooler for stream number 1. And you need heater for stream number 3. Nampak? So far so good?
Faham, Miss.
Nampak kan? Faham eh? Okay.
Yeah.
Now, nak save lagi? Boleh. Alright. Why should we waste the energy? Tengok sini. This one ada 90 kilowatt lagi. Dia perlukan 90 kilowatt. Sini ada extra 110 kilowatt. 110 kilowatt. Tengok, boleh ke nak bagi? Saja je pandang dulu kan. Alright. Sini, you perlukan heater. Sini, you perlukan cooler. Boleh tak kita kahwinkan 3 dengan 1? Boleh tak? Boleh tak?
Tak tahu.
Tak tahu? How come you tak tahu? Sebab energy required untuk stream number 3 110 kilowatt. Okay. Alright, maksudnya dia perlu absorb 110 kilowatt lagi untuk reach 135 degree. Dia perlukan energy, heat energy to reach 135 degree Celsius. Yang ini pula dia perlu absorb. Dia perlu release the energy. Sini nak release, sini nak absorb. Dia boleh lah match. Dia nak absorb, sini nak release. Dia macam suka sama suka lah kan? Suka sama suka. So you can match another network which is from here to here. Sini ke sini. Ni. Saya buat yang merah lah. Sini ke sini. Boleh. Okay. Right? Boleh. Alright. So dia ambil berapa? Dia akan ambil sini akan tolak. Maksudnya energy required kena tolak 90. So tinggallah 20 kilowatt. Okay. Dan sini tolaklah 90 kilowatt. Settle. No need to have cooler. Okay. You don't need the cooler to reach 60 degree Celsius for stream number 1. And at the same time, you reduce the energy required for the heater. Okay, for the heater here, okay, you reduce the energy required for the heater so that the heater only required 20 kilowatt only. Nampak tak? How you save the energy. How you conserve the energy. How you exchange the energy. Okay. So you dah nampak macam tu lah proses tu satu. Okay, just nak berimagine, you need to imagine maybe lah. Okay, so nak imagine macam mana? Okay. Boleh tak berimagine? Saya ajak you imagine lah. Okay. So the way how you solve the problem is not susah sangat untuk selesaikan masalah tu. Okay. Jadi what you can do is to do the separation lah. Okay, part by part. Okay. So you can follow this method. Okay. First, you need to have the idea first. Okay, idea you mesti ada dulu. Right? Idea you mesti ada. Okay. So this is the moment you have 90 degree Celsius. Okay. Sebagai hot stream punya pinch temperature. Okay. So semua orang kena faham So because your test will be on Monday next week. Early in the morning, 1 hour only untuk you berfikir dan do the calculation. Okay, so everyone might have different choices. Okay, everyone will have different choices. It doesn't mean that your friends select stream 1 and stream number 4 and you select 1 and 4 also. It doesn't mean that way. So maybe your friends would like to choose 1 and 3. Okay, stream number 1 and stream number 3. So it depends on how you can see the problem. Okay, how you can see the problem. What you need to understand is that hot stream always release energy. And that release energy should be absorbed by the cold stream. Okay. So hot stream will release energy, okay? And cold stream will accept the energy. It will absorb the energy, all right? So if the energy is not enough to be transferred, therefore you need extra cooler for your hot stream. If the energy absorbed is not enough for the cold stream, then you need heater at in front of the outlet, in front of the system, the stream, before you have achieved the final temperature that you would like to reach. Tu kena faham kat situ. Okay, nah, saja je tengok ni. Okay, tengok je dulu. Okay, how you solve the problem. Okay, all right. Nampak decision kita. Okay, all right. So lain kan decision ni? Can be different, can be the same. Okay, all right. So this is the one that you have decided. Okay, which is to have to complete the process. Okay, to complete the process. All right. So how much heater that you need, how much, okay, based on our assumption just now, nampak? Beza kan? Beza. Kita cuma perlukan heater at stream number 3. Stream number 3. Okay. And the heater is only required to have 20 kilowatt sahaja. 20 kilowatt of heat energy. Alright. But if you refer to this example, okay, so dia buat apa? Dia cuma hasilkan berapa heat exchanger? Cuba kira. Berapa heat exchanger? Cepat. Gambar dia depan mata tu. Heat exchanger only have 2 stream. Stream number. Okay, 2 stream. 1 hot stream, 1 cold stream. That is the theory. Berapa heat exchanger here? Tengok gambar betul-betul. Cepat nak belajar kan? Any respond? How many heat exchanger here? Can you tell me? Stream number 1 and stream number 4. Berapa heat exchanger? Stream number 1 and stream number 4. How many heat exchanger? Tidur ke? Berapa heat exchanger?
270 ke bu?
Saya tanya berapa bilangan heat exchanger, berapa unit heat exchanger kalau you ada stream number 1 and stream number 4?
2.
Oh. Ha.
Tu, saya tanya kalau you ada stream number 1 and stream number 4, how many heat exchanger here? Apa? Nak jawab pun takut. Macam mana nak buat soalan exam?
2.
Cepat. Berapa? 2. Okey. Ada jawapan lain tak? You kena faham soalan saya. Saya tanya, kalau you ada stream number 1 and stream number 4, you said you have 2 heat exchanger. Jadi dia punya jawapan dia macam ni lah. Okay. Sekejap ya. Ni saya nak translate you punya kefahaman. Okay. Stream number 1 and stream number 4 in this diagram. So you have heat exchanger and you learn about heat exchanger. Okay. That you have 2 streams, hot stream inlet and hot stream outlet. So the hot stream inlet has 180 degrees Celsius and the outlet is 60 degrees Celsius. And then stream number 4, which is considered as hot stream, cold stream, the inlet is at 80 degrees Celsius and the outlet is at 140 degrees Celsius. Okay. By looking at the drawing that I show in front of you, how many heat exchanger that do you have?
1 only.
1. Kenapa boleh jadi 2? 1 heat exchanger need 1 hot stream and 1 cold stream only. Okay. 1 heat exchanger need only 1 hot stream and 1 cold stream. Okay. So, kalau nak beza juga, nampak beza ni. Ni hot stream adalah color merah. Cold stream color biru. Ada 30, ada 40. In this case lah. Saya buat case yang ini. Okay. Now, I ask you again. What about stream number 2 and number 3? How many heat exchanger do you have?
1.
1.
Okay.
One.
For stream number 2 and 3, you need 1 heat exchanger and 1 heater. If you look at this diagram, looking at this diagram only. Alright. Okay. 1 heat exchanger and 1 heater. Jadi macam mana you nak lukis? Okay, lukislah macam biasalah. Draw the box. Okay, draw the box. Okay, so you have the box already. And then you ada hot stream masuk dan hot stream keluar. Okay, and then you ada cold stream masuk dan cold stream keluar. Okay, so cold stream you have to reach 135 degrees Celsius because cold stream perlukan heat to be absorbed. Okay, because they're lower. And then here is the inlet is at 20 degrees Celsius. The hot stream that you have 150 degrees Celsius and 30 degrees Celsius to cool down. Okay, right? So you need 1 heat exchanger here. Okay, one heat exchanger for stream number 2 and 3 and one heater. Okay, one heater. Therefore, you need to install heater here. You need to install heater here. Okay, you need to install heater. Okay, to install one heater. Okay, before you can send this to another process. Tu maksud dia. Kenapa you need preheater before it's enter to other process equipment. Okay, for example, this is one example lah. Macam tiba-tiba you nak masukkan dia dalam distillation column. Contoh kan. Kan ada preheater kat depan tu. Okay. So you masuk dekat you punya DC. So DC you ada top product dan you ada bottom product. Okay. Alright. So you need certain condition of the feed for your distillation column. Something like that lah. That's why you need heat exchanger. Okay. Alright, so if you look at individual diagram, then you can see only preheater. Okay, but now we can reduce the amount needed to increase the temperature of your feed by using heat exchange network. Okay, maksudnya yang ini datang mungkin daripada reactor. Okay, this stream mungkin datang from the reactor. Okay, mungkin ada reactor kat depan ni. That's why the feed, the product comes out from the reactor here has higher temperature, the product that you have. But before you can collect the product, you need to cool down the product. Instead of, okay, saya bagi contoh ya. Nak bagi you faham, you kena faham. Okay, let's say you ada reactor. Okay, you masuk produk you kan. So this is reactor. Okay. So when you collect the product from your reactor, okay, you collect kat sini, right? Dia punya temperature adalah 150 degree Celsius. Okay. Instead of exchange the energy, you perlu install cooler kat sini. Cooler. Alright. So that you can have your product at room temperature, for example, 30 degree Celsius. Okay. Jadi sekarang ni tak payahlah. Dia cuma exchange the energy. Okay. Exchange the energy by having apa? Ni permainan. You kena faham, jangan ambil ringan. Because you need to understand. Alright. You dah learn about heat energy. You learn about equipment. You learn about design. Okay, so this is the information that you need to have. Okay, so instead of having that, sekarang ni kita akan buat dia dalam keadaan macam mana? Kita akan buat dia, ini reactor. Okay, reactor. This is the feed. Feed 1, feed 2 yang you ada biasanya. Okay, and then your product. Okay, your product ni, dia perlu lalu heat exchanger saja. Okay, lalu heat exchanger. Okay, tak cantik. Nanti kita buat cantik. Because that is considered as hot stream. Jadi heat exchanger you bentuk dia macam ni lah. So ni masuk, ini keluar. Okay. So yang nak keluar tadi, yang masuk tadi adalah 150 degree. Dia masuk 150. Okay. Dia masuk 150 degree Celsius. This is the condition of the stream. Dan dia mesti keluar dalam keadaan di mana dia perlu keluar dalam keadaan 30 degree Celsius. Okay. Alright. So, paling mudah adalah untuk you nampak benda ni supaya you boleh apply cold the feed that you want to feed into the distillation column. Lukis je kat mana-mana. Okay, let's say saya lukis kat sini. Tak ada tempat nak lukis lah. Okay. So this is your DC. The green color ni your distillation column. Dan you need your feed to be, you punya feed you nak dia pada berapa tadi? Pada 135 degree. You nak ni. Pada 135 degree Celsius. Jadi biasanya you install heater kat depan macam case yang tadi tu. Biasanya you install heater untuk because at room temperature you have 30 degree, 25 degree Celsius of feed material for your DC. So DC ada 2 outlet. Let's say minimum 2 outlet. Okay. So instead of installing preheater in front here so that it reach 135 degree. Okay, 135 degree. Mana tadi 135? Okay. So tadi kan dia 20 tadi kan? Ya, 20 ni. 20 ni. Maksudnya at room temperature let's say 20 degree. Sekarang ni kita tak nak dia 20 degree. Okay, jadi the feed for your distillation column, okay, lalu sini lah. Lalu sini dulu. So this is at 20 degree Celsius dia lalu. Dia keluar, tak perlu ada heater, terus saja masuk. Terus saja masuk your distillation column. Okay, because it reach 135 okay. Tu maksud dia. Okay, 135. Cukup ke? Cukup ke nak terus 135? Kalau ikut gambar ni tak cukup. Ya, dia tak cukup. Okay, kenapa tak cukup? Okay. Sebab kalau ikut gambar ni, okay, you perlukan heater sebanyak 50 kW lagi. Okay, sebanyak 50 kW sahaja. Alright. So you perlukan tadi Coldstream perlukan 230 kan? Tadi 230. 230. You refer balik lah. Saya tunjuk je. You kena faham, this is technical. Yang ini tadi kan, yang atas ni hot stream 120 kilowatt. Yang bawah ni adalah 230 kilowatt. Okay. So dia dah ambil, dah match yang ini. Jadi tinggal berapa tadi? 120. You ada 90. 100 berapa? Berapa ni? 80 dengan 30. 110 kan? Difference dia.
Yes, miss.
110. 110. Okay, 110. Right, difference dia 110. Okay. Right. So, you dah tolak. Dah tolak dekat stream ini. Dah tolak berapa? 230 tolak 120, you dapat 110. Okay, dapat 110 sebagai contoh lah. 110. Okay, jadi you kena buat apa? Saya tak nak di-confuse dengan gambar ni sebab you kena faham dulu apa yang you buat. Okay, so the hot stream settle, tak ada masalah. Hot stream settle, tak ada masalah. Tapi cold stream ada balance lagi 110 kilowatt. 110 kilowatt lagi dia perlukan. Kalau you tengok sini, dia perlukan 110 kilowatt lagi. Alright. So kalau 110 kilowatt, apa yang perlu buat? Ini secara keseluruhan ya. Yang ni kita tak nak bahagikan lagi kat sini. Pandang keseluruhan je dulu. Right, pandang keseluruhan. Kalau ni you punya choice. Pandang keseluruhan. Okay. So, by having that sebenarnya kat depan ni ada preheater. Akan nampak lah ada preheater kat depan. Sebab you ada kat sini kena ada. This one, sorry. This one, you mesti ada heater. Kat sini lah letak heater tu. Heater tu. How much? This is the difference. Okay, sebab kita dah settle yang depan semua tanpa lihat pada pinch. Tak tengok pun pinch ni lagi. Okay, tak tengok pun pinch ni lagi. So, I'm talking about from the beginning to the ending. From the beginning to the ending. Okay, so this is how it looks like. Kalau you nak nampak. So, basically, just looking at this overall, you kena ada satu preheater kat sini. You need to have preheater dekat sini. Okay, perlu ada. And the watt is 110 kilowatt. So kalau it's involved for this particular system. Okay. Sebab tu saya kata everyone will have different way to solve the problem. Okay, so that's why this one when you use the heat exchange network. Okay, heat exchange network. Okay, so tadi tu you look for the overall. Okay, overall. So now is the time for look for the pinch. Sekarang saya nak tunjuk you pinch pula. Okay, so jangan confuse overall without pinch. Now you have to look for the pinch. Okay, look for the pinch. Okay, so the pinch, okay, the pinch given to you here. Okay, right? Tengok ni betul-betul. Okay, alright. Benda dah ada, jadi you kena fikir sekejap. Bagi saya value that you think that you would like to require. Okay, alright. Sekarang ni tengok 90 degree. Okay. 180 ni 180 sampai 90 degree ni berapa degree? Berapa degree?
10.
10 degree?
90
Macam-
means.
90. So the difference here adalah 90. Okay, difference in temperature is 90 degree. Okay. Boleh bagi tahu saya berapa heat load? 90 multiply by heat capacity which is 3, which is 200. Cepatlah.
70.
270 kilowatt. Okay, kita kena buat satu-satu lah. Okay, sekarang the next one. 90 degree dengan 150 degree. Berapa change in temperature? Untuk stream number 2.
60.
60 degree Celsius. Berapa kilowatt? Stream number 2, you have to multiply by 1.
60.
60. Okay, 60 kilowatt. Okay, tengok yang bawah pula. Stream number 3. Okay, stream number 3. 90 to 135. Berapa degree?
44. 45.
45 degree Celsius. Energy. Heat load berapa?
90.
Dia number 3 kan? 2
Yes.
times 2.
Yes.
90 kilowatt. Okay, bawah pula. 90 to 140.
50.
50 degree Celsius. Berapa kilowatt?
125.
Darab dengan 4.5.
225.
225
25.
kilowatt. Oh, okay. Alright. So sekarang ni sempadan you lah. Sempadan you adalah yang warna ni je. Okay. Alright. Okay. Now. Tapi ingat balik. Bukan ke cold stream kita tadi perlu bermula daripada 80 degree? Okay. Dia perlu bermula daripada 80 degree. Jadi stream yang terakhir tu sebagai contoh 140 degree kena tolak dengan 90 degree lah. 80 degree. Okay. 140 tolak 80. So you get Apa 80? 140 tolak 80.
60.
Dia dapat 60. Betul, 60 kan?
Yes.
Darab dengan 4.5. Okay, darab dengan 4.5. Okay, so, okay, jadi jangan terkeliru. Itu saja nak faham. Jangan keliru. Hot stream, dia ambil yang kotak biru. Hot stream. Cold stream, dia ambil kotak hijau. Okay, dia ambil daripada 80 degree. Okay, sebab pinch untuk hot, 90. Pinch untuk cold, 80. Dia macam tu. Sebab kita ambil 10 difference. Okay, so now, jadi yang ni salah kira lah. Kena kira balik. Ni salah kira ni. So yang hijau ni berapa? 135 tolak 80. You got 55
55
times 2. 110 kan?
Yes.
So you ada 110 here. So tu cara you kira. Belajarlah kira. 10 kilowatt. Okay. Alright. Then dia kahwinkan. Dia suka nak kahwin kan. So yang ni tadi dah salah. Ini kena padam. Ni. Okay. So ini adalah 60. Belajar sehingga pandai. Okay. 60 minus 4.5.
270.
270. Okay. So you ada 270 kilowatt. Okay. Right. Okay, tengok. Betul tak? Kita kena agree dengan tak agree je sekarang. Dia dah buat dah untuk kita. Tapi you dah faham dah tadi. So once you dah understand, then tengok. Boleh ke dia match stream 1 dengan stream 4? Stream 4, dia ada 270 kilowatt. Stream 1, dia ada 270 kilowatt. Boleh settle tak? Stream 1 perlukan cold water at 270 kilowatt. Dia perlu release. Siapa nak terima nikahnya? Stream number 4 kan?
Yes.
Yes, miss.
Dua-dua agree. Sama banyak. Fair and lovely. Fair and lovely. Okay. So you can build one heat exchange yang kat sini. Antara stream 4 ni dengan stream ni. Okay. Yang ini objektif dia to reach 90 degree sahaja. Yang ini objektif dia to reach 140 degree. Nampak tak? Okay. So you kena nampak itu dulu. Okay. Tapi settle lah. Dan dia bermula nanti dekat tempat lain. You kena pandang dia. Hot stream dia ada 90 degree kat sini. Dia keluar pada 90 degree. Nak masuk dekat heat exchanger lain. Dia dah multiple lah. More than one. Okay. Because sometimes kita tak nak over duty. Over duty the heat exchanger. Kan? Kalau heat exchanger tu over duty, nanti dia cepat rosak. Okay. And then they are very expensive. Heat exchanger yang besar-besar ni sangat expensive. Okay. So that's why sometimes they like to have a smaller one. So that it costs less. Okay. Alright, so settle, tak perlu buat apa-apa untuk yang ini until this particular sempadan. Okay, tengok. Ni. Matching tak? Stream number 2, dia perlu release 60 kilowatt. Stream number 3, dia perlu absorb 110 kilowatt. Boleh match tak? Yang penting boleh match tak? Apa panggil? Sekufu. Sekufu tak ni? Agree tak? Sekufu tak? 60 dengan 110. Sekufu ke tak? Allah, lambatnya nak jawab. Nak switch on mic pun susah. Siap awak nanti. Boleh tak? Boleh tak 60 dengan 110 ni? Boleh tak? Boleh tak dijodohkan?
Boleh. Rasanya
Boleh. Okey, boleh. Cuma
Finish absorb.
cuma dia dapat absorb 60 saja. 60 kilowatt saja. Dia perlukan 110. That's why you need to produce heater kat sini. Sebelum you capai 135 degree Celsius. So the heater power should be 50 kilowatt. Okay. Ini untuk study yang ni. You kena faham. Nak study heat exchange using pinch temperature. Using pinch. Alright. So tadi tu kita buat secara manual. Okay. So now you follow this one. Okay. So you just need 50 kilowatt. Okay. Now tak settle lagi. Depan ni tak buat lagi. Okay. Alright. Sekarang kita kira sekali lagi. Kira lah, kalau tak dia tak nampak. Ni last one ni. Nak habiskan kelas cepat ni. Dia tak habis-habis kelas. Okay. Now, daripada 90 sampai 60. Berapa degree Celsius? Temperature berapa ni? 90 to 60? 30 degree Celsius. Saya tak nak cakap seorang-seorang. Tolonglah bercakap dengan saya. Okay. And then here, 90 to 30, berapa temperature dia? 90 to 30?
60.
60 degree Celsius. Lagi bawah. Kita pergi bawah dulu. Okay, bawah ni 80. 80 to 20. Berapa temperature?
60.
60. Bawah lagi. 80 to 80. Berapa temperature?
0.
0.
Yes.
Jadi, tak ada buat apa-apa lah. Settle dah. Kan? 0 degree. Nak buat apa lagi? Kali dengan power, dapat 0. So, tak perlu apa-apa. So, memang you akan dapat 80 degree. Settle. Bawah ni. So far, stream number 4 settle. Okay, now, tengok. Okay, 6. Okay, yang 30 ni berapa power? Kena kira power dia. Berapa? 30 darab 3. 90 kilowatt. Bawah ni 60 kali 1. 60.
60 kilowatt.
Bawah
120 kilowatt.
120 kilowatt. Bawah sekali tak payahlah, dah habis dah, settle lah. Tak payah buat apa-apa. Okay, sekarang study balik. Dia nak match ni, dia dah match. Stream number 4, dia nak matchkan dengan stream number 3. Okay, stream number 4, dia matchkan dengan stream number 3. Stream number 3 ada 120 kilowatt. Stream number 4, 90 kilowatt. Okay, maksudnya cukup tak untuk dia match? Cukup kan? Okay, cukup untuk stream number 1. Berlebih untuk stream number 3. Betul? So, stream number 3 ada lagi balance berapa? Ada balance lagi 30 watt. So, stream number 4 settle. Stream number 4 settle already. Okay. Stream number apa mana dia? Mana dia? 90 dengan 120 ada 30 kilowatt. Okay. So, stream yang ini tak settle lagi. Okay. Ada lagi 30 kilowatt. Ada lagi 30 kilowatt. Dah sedekah dekat stream number 3. Okay. Ada balance lagi 30 kilowatt. Okay, so now tengok stream number 2 dengan number 3. Number 2 dia nakkan 60 kilowatt. Number 3 cuma ada balance 30 je lagi. Boleh tak ambil? Boleh tak? Awak jangan pening. Muda lagi untuk pening. $120 kilowatt. Okay. So sekarang tinggal 30 kilowatt. Okay. Tinggal 30 kilowatt. Okay. So 30 dengan 60 kilowatt. 30 and 60 kilowatt. Maka settle lah stream number 3. Okay. Tapi stream number 2 memerlukan lagi 30 kilowatt. 60 tolak 30. Dia ada lagi 30 kilowatt. Jadi dia nak cool down, dia perlukan 30 kilowatt. That's why you need to install a cooler in front here, which required 30 kilowatt cooler to reach 30 degree Celsius. So barulah settle stream number 3, number 2. Okay. So, soalan. Okay. So, tolong faham betul. Okay. If you were to use the pinch temperature, and you are given the temperature, okay, difference between the cold stream and the hot stream is 10 degrees Celsius. Okay, so therefore you need to decide that when you talk about hot stream, the pinch temperature should be higher, which is 90 degree, and the cold temperature or cold stream temperature should be 80 degree. So that one, if you took delta T minimum to be 10 degree Celsius. Okay, 10 degree Celsius. If you are given delta T minimum is 10 degrees Celsius, then you are also given the hot stream pinch temperature is 90. Therefore, it is automatically, you should know the pinch temperature for the cold stream is 80 degree. Okay, and then your job when you want to use this heat exchange network using pinch technology, okay, or pinch analysis, okay, you have to calculate everything based on this method. Okay, based on this method. Okay, so conclusion, you have to make conclusion. How many overall? Okay, how many? Okay, how many cooler? How many heater? How many heat exchanger that is required for this network? So you just calculate. Okay, so number of heat energy. Okay, number of heat exchanger, sorry, is equal to A, B, C, D, which is 4 units. Okay, number of cooler is equal to 1 unit. Number of heater is equal to 1 unit. So the power of the heater is 50 kilowatt heater. The power for the cooler is 30 kilowatt cooler. Okay, all right. So this is the specification of the of the utilities equipment that you need. Okay, so dia macam itulah. Alright, so you ada 4 stream. Okay, you might want to have 4 unit heat exchanger, 1 cooler, and 1 heater. That's all. Jadi after this, you can calculate the cost. Okay, 4 unit heater. Okay, how much that you can have. Okay, if you look at this, kalau nak tengok heater yang pertama, okay, let's say heater, the first heater. The first heater X1 is equal to berapa power dia? Power dia adalah 60 kilowatt. X2. Berapa power dia? B 270 kilowatt. X number 3. Berapa power?
90
power?
kilowatt. 90 kilowatt.
90 kilowatt. Okay, and hex number 4. Berapa kilowatt?
30 kilowatt.
30 kilowatt. Jadi, when you want to buy a cooler, you want to know the cost of cooler, you look for the heat exchanger specification that you require. Nampak? You as a process engineer, you are dealing with the process. You know what temperature that is required by your stream for the process. It can be separation process, it can be a reaction process, okay? So you know this one. You are the one who designed the process. So in this subject, you are the chemical engineer. You design the plant. You design the process. Now it's time for you to design the utilities. Okay, to design the utilities required for the whole plant, for let's say. Okay, so this is one of the example of streams that you have in the plant. You only have 4 in this case, but in the real plant, you have many streams. So you have to know which one is the major stream, which one is the minor stream. You have to know that. Okay, so by looking at that, you do the analysis. So these are the analysis. How much energy is required for your utilities? Okay, so if you can reduce the requirement of utilities, then you can save the cost for the company. You save the cost, you reduce the cost, meaning that you contribute a very important opinion for the company. Okay, so this is a very good practice for you. Okay, so if you were to involve in the industry later, this is what we want from you.